So Exploratory online seminar number 33. Today, I like to present Exploratory version 6.4, which we released last Friday. There are many new features, enhancements, and then bug fixes. And then the detail you can find, I mean, a list of those can be found in a release note. But today, I like to highlight some of the new features and enhancements. Okay, so the area of new features and enhancements, the summary view, that's the view you first you see the first thing you see after you import the data, and then like analytics, and then visualization, data wrangling, reporting dashboard, and the data source. I listed data wrangling here. There are enhancements there, but I'm not going to talk about because they're not big new features or enhancements there. So other than the data wrangling, I like to go through like a summary view, analytics, visualization, and data source reporting. Okay, so start with the summary view. In the summary view, that gives you the summary information of each column, right? But there is a mode you can click on the button called correlation, and then the mode called correlation mode, where you can find the relationship between the subject of your interest, what let's say like monthly income or like sales or whatever, and then with all the columns or variables. Um, so this is a great tool. You can find a correlation related or like association type of information. um, if you're interested more about the correlation association stuff, then I have done exploratory data analysis part 2 online seminar, and that's where like I talked about correlation and association. So it's been recorded and it's posted as well. So you might want to check that out. Um, Besides that, so in this correlation mode, we keep improving, but this release, we added extra statistical test shortcut. So let's say like you want to click on the business, this is like employee data, and then we are trying to understand the relationship between the monthly income and other variables. And let's say like there's a business travel column or gender column, and we want to find out like the monthly income is different or not. And there are various ways to test the hypothesis. And so you can, we have added t-test, ANOVA, Wilcoxon. I mean, those were already there under the analytics view. So this is a shortcut from this column header menu. You can create those analytics right away. Okay, so that's a summary view. And the analytics, we added a couple things, and then the most exciting thing is a time series clustering. I'm going to talk about that in more detail. And we improved the time series forecasting with Prophet by adding a monthly and quarterly seasonality. And also, we added the survival models as part of the prediction framework that we added in the previous release. And then we improve the summary sample size setting as well. So let's start with the time series clustering. So this is really interesting. So the whole point is this is kind of easy to understand the concept itself. You have the time series data, and then sometimes you want to group that into a number of clusters or groups based on the similarity, right? So sometimes like you have like kind of even a stock price, time series data, sales data, number of employee data, any type of incidents or any type of the time series data. Some of them have a similar sort of the trend, same time going up and going down, or at the same price range and then lower price range and so on. So based on such characteristic, very specific to time series, and you might want to group into some clusters. So, this a little bit tricky with the time series data. It's not as sort of like calculating the distance or just simply calculating the correlation between those two, three, whatever the time series data. So that's where there's something called dynamic time warping algorithms come in. So our time series clustering use that this algorithm. So let me talk a little bit about it. Dynamic time warping is used to compare the similarity or calculate the distance between the two time series data with different lengths and the speed. When I say speed, meaning is a sort of like a acceleration of going up or going down. There's a timings might be different. One is kind of like a quicker, the other is a little slower. But at the end, both of them might have same type of patterns. So that's what I mean by speed. So, for example, when you see this blue line and then red line, obviously, like seems like it, these have similar patterns, but the problem is the like a blue line goes up first and the red line goes up a little later, and then like after that going down, both lines going down and going up and so on. And also the blue line has a longer length at the end, but the red line stops at before the blue line. So in this case, when you just kind of based on the time points and then calculate the distance on this kind of vertical line, and that's one way to do it, but you might not necessarily be calculating the exact sort of the distance we intuitively expect. Well, what we expect is something like this, because this line, when you look at this like kind of like a connection lines, like try to point the peak and bottom and bottom. So that's one thing. And also try to, for all the points being sort of like mapped. So even like at the end, the, seems like the red line ended up as sort of a kind of a peak, right? There's another mountain, blue line as well. So that's the part being connected. And then, so other lines between the peak and bottom is sort of like becoming a little cricket. Um, Better way to visualize this is again, so this red line and the black line seems to have the similar pattern. So we want to consider this as the same, but if you calculate in the vertical lines, and we might end up like over calculating that distance. So therefore, like if we are talking about just two, that's fine. But if you're talking about 50 lines and 60 lines, we might not be calculating the distance in a way of finding the similar lines, right? So that's where this sort of something called one-to-many matches that like this algorithm can find. So like a bottom to bottom, peak to peak, and then between it try to actually not necessarily like the same sort of like equal width or something. But for example, easy visualization of this is like a very right hand side, and then there's a one point at the black peak. From there, there are maybe like, I don't know, like 20 lines going up. And that's what I mean by one to many. But by doing this, so this one, sort of like there's a time lag between the two lines, but try to calculate is more like appropriate. And in other way to say is minimize the distance between the two time series data. And then by doing this, when you have many time series data, it's the result of the similarity that this algorithm can find is much better than just simply calculating that distance on the time points on the vertical, horizontal vertical. So by doing so, so for example, this is COVID-19 number of deaths per population data, and then you can see sort of like a similar patterns being identified. And then like based on this, maybe you can find, hey, is there any like sort of geographical relationship or any sort of like a population or a characteristic of a demographic of each state, United States, maybe that can be detected by this, by separating the cluster. Okay, so I think it might be better if I give you some demonstration here. So this data is like Oxford University in the United Kingdom. They actually collect this information called lockdown stringency. What it is for each country and each, for example, in the United States case, each state, and it tried to see like what is the strength of the lockdown based on, for example, school closing, workplace closing, or stay-at-home requirement, and then all sorts of different things. And then eventually they create this thing called stringency index. That's an index. So I was wondering, so this actually I filter only for the United States data for this demo, um, and then I visualized it. So this is all the United States, I mean 50 states basically. And some, for example, states like Hawaii has higher stringency, like they super hardcore lockdown. And compared to, for example, some states like Florida has been open since last September. So many states, I mean, each state has a different type of policy or the way of doing so. And so I was wondering, can we group these lines into, let's say, multiple groups, let's say like 5 or 6 groups, and then I want to find any characteristic behind it, right? So that's what I was trying to do. So let's run this clustering thing. So here, we haven't exposed this under the analytics view, so that's one thing. Probably we are expecting to do so in the next release, but with this release, you can create the data wrangling step. What I mean is that data wrangling here, right-hand side, this is the data wrangling side of things. So here, there's a plus button. You can add extra step. So I want to go to the make sure like I'm at the last step. This is where like I want to add the extra step for doing analytics. I can click on the add a new step or like this plus button. Either way, this you get the same menu, and then you see this run analytics. Under that, there is a time series clustering. So that's a new menu. When you click on it, and then all you need to do is sort of like you're creating that same line chart. So select what's a group. In this case, I'm interested in this country. Is that a country name with a United States or region name? So region name is the group. And then time axis, I want to find based on the day. And then I want to aggregate the stringency index. Let's find it. Oops, index here. And I want to make sure just me in case there might be multiple data points. And then there are columns for each state, like a party information, which is either Democrat or Republican based on who's a governor. So I'm going to select that one because I'm going to use it right after this. Mode is the function to pick up the most frequent value. So in this case, there's actually only one, but in case there are two. Anyway, so under here, number of the clusters, I want to set like 6 groups. And this, like how many numbers you want to set, there's no clear answer, especially like something like a clustering. So like what you want to do is like you want to experiment, 6 or 3 or 4, and then look at by visualizing it, and then see like whatever the cluster number of the cluster that makes sense to you, that's the number you want to use. I mean, that's how I recommend. Anyway, so I'm gonna just click on Run button here. The default, you have a variation of the different slight variation of the methods to do the clustering, but based on pretty much either way, like you're using that dynamic time warping and algorithm, and there's some like variations to it. Okay, so here I got this one. So this is a new column, the cluster. That's the column where I have the cluster ID. And what I can do is I can just go to the chart view, and then right now the step is on the step before the clustering, but I want to get that cluster number which is generated in this step. So I'm going to move this pin button. I'm going to just click on it and then click again, or I can drag and drop either way. And what I want to do is the color is this like a region name. That column has that state name. The default, it creates other group because there are 50 and there are too many. And so like it picks up the most frequent top 20 and then make everything else to be other group. In this case, I don't need that. So I'm going to just select that none button. So now like what you're seeing is basically the chart that I originally had, right? So there's 50 lines. And from here, I'm going to use the cluster ID to separate into 6 different charts. And you see kind of like, similar patterns being detected, right? So for example, these cluster 1, Delaware, Virginia, and Maryland, these seems to have like similar patterns. And by the way, so this strength, how strong is the lockdown policies? I would say like this 60 is kind of like sort of like a threshold. If you the strength is less than 60, pretty much the state is open. If it's higher than 60, you realize daily life like, hey, things are still closed. So I'm gonna add the reference line to just set the uh, let's say like 60 as a guideline. So let's say like maybe like a red color. How about something like this? Okay, so that's the threshold. And then when you look at this one, for example, 50, no, sorry, cluster 5, all the states basically becomes harder, stricter lockdown. But then these states start coming down. So now most of the states in this group are less restrictive. And then, for example, this one, number 4, this is where like all the states are higher than the 60, but not only higher, but consistently from the beginning to even today has been super restrictive. So there seems to be like a different kind of characteristic. And then this, for example, number 1 become easier and then harder now. So there's different patterns here. Now I want to find out what are the characteristics. And one of the way is that the party is like a Democratic or Republican based on the governor. So that doesn't mean that state is a Republican or Democratic party, but I'm just using the governor as a proxy. And then so I created this pivot chart, no summarized table, and each state, and then it has the party based on the governor. So for example, Alabama has a Republican governor and so on. And I want to actually bring in the cluster information. So let's say, what is the cluster numbers? So here, I gotta move that ping to the last step. And then because this number 14 has that information. So let's say cluster numbers, and then next one is what I want to do, the state here. And then the last one, the party, is the, name of the party. And I actually use the color to give red color to the Democrat and blue color to um, did I say the right thing? Oh, this is actually opposite. So usually, Democrat should be considered as a red color. So I'm going to just change that color, reverse the color. Here we go. Okay, so that's more for the American point of view. It's more intuitive color. So now here you can see, for example, that you may remember the number 5 is less restrictive here. And it tend to have the Republican governor, though there are some Democratic states as well. And then you remember the hard one, the number 4 here, tend to be blue states, which is a Democratic states. And then, so you can see some sort of like based on the governor, it's a different policy. I mean, a different strengths of a lockdown. I'm not going to go into like a lockdown is good or bad or that kind of stuff, but it's just a good demonstration. This is how you can use. So imagine like if you have sales data or number of customers data or number of incidents data, you can use this time series clustering, separate into the groups, and then you can use that information with combined with other demographic information or other characteristic information, and then see what correlates, what associates, and so on. Okay, so that's the time series clustering. Pretty exciting stuff. And then other thing is time series forecasting. We use Prophet to do that. And that's also, we added the quarterly and monthly trend. So let me just quickly show you what this is. So for example, when you have the data like this, and then I'm gonna create the Prophet forecasting. So this is a sort of sales data, and each row is each order for what which customer order what products kind of information. And then like I want to see, I mean, there's a sales information, like how much of the order being sold. So by using this, I like to sort of forecast what is going to happen. So like by using this model, so I'm going to select the time series forecasting here, profit. And then date and time column, I'm going to just select the order date. And I'm going to just make that a sort of weekly aggregated data for forecasting. And I'm going to select the sales to forecast. So when I click on run, then like I get this forecasting model, and then this orange line is the forecasting value, and the blue line is the actual sales values. And then I could say like if I like to, right now it's a weekly aggregated data, that unit is time unit is week. So I'm gonna set 52 so that I can forecast the whole next year, right? Like 52 weeks. And then like I can forecast it. By doing this, profit is basically detecting or finding the patterns in the seasonality. And it used to be like this yearly in this case, and then also it can do daily, weekly, like Monday, Tuesday, Wednesday kind of pattern. If you are your aggregation, if you set this one to the day level, right now, like I said to the weekly, so like it is using only the yearly and the trend, and then get the predicted forecasted values. But here we have added the seasonality section. There's a quarterly, so you can check that to true, and also monthly as well. And so what that means, if I run this and then profit use that information, and then the seasonality is all about repeatability, right? So it repeats the same thing. So for example, this yearly, what we are seeing is, typically what happens is like, hey, like a June time, like the sales goes up, and then July times goes down, and then August times goes up, and so on. So those similar patterns that repeats every year. So that's the yearly seasonality. But when you think about it, there should be some patterns in the quarterly, especially in the business world. Some sales goes up at the end of the quarterly for some reason. So this is quarterly. So like it's basically you see like from 90 about 90 days, and then in the profit thinks that's sort of like a repeated period, and then in that period sales, how the sales works. So for example, as we expect, sort of like towards the end of the quarter, like a sales goes up and then goes down, and the next quarter again it's always starts from kind of a slow start and then goes up towards the end. So this repeats every quarter. And how about the monthly? Monthly is like from the first day to end of the month, typically 30 or 31 or so. And in this one, this pattern has been detected, and then Profit is using this to do the forecasting. And then when you go to the effects tab, then you can see what seasonality and the trend that Profit is actually using for the forecasting. It is using all of them, but when you look at here, seems like yearly seasonality is more sort of like the variations so higher. So that means Profit is actually using it to get these forecasted values. When you go to the importance, you can see which one is more useful for the Profit to do the forecasting, to make sure the forecasted value is similar to the actual values. So that's the new added seasonality. Okay. And then prediction with survival models. You can build the models, and then you can predict, right? So we added this prediction capability by using the model you create under the analytics view in version 6.3, or could be 6.2. I don't remember, like so many versions, but we have added this as survival models into the prediction framework with this release. So what that means, so when you go to, let's say that I'm going to use the same employee data. This data conveniently like each row is each employee, and then but at the end, the start date and end date right? So when the end date is NA, that means this person is still working. But if you see that some date, that means this person has already left the company. So we can see, we know the sort of the period of each employee working. But based on this information, we can create the survival model. In exploratory, there are two models. I'm going to just create a new one. One is a Cox regression, which is a statistical learning model. And the other one is a survival forest, which is actually survival random forest. It's basically a machine learning model to predict survival rate or survival curve. So I'm going to use a survival forest for this demo. And then I'm going to set a start date and end date. And then period by, I'm going to keep it odd. And the event is attrition, either if this given employee has left or not. Predictor variable, I'm going to use all of them other than time sensitive information. So like age and then monthly income, total working years. I'm removing monthly income because I already know this one is highly correlated with some of the variables here. So usually you don't know, so then you cannot do an experiment, but I already did it before. So I'm going to just remove that. And then I just run it. So this point, I've just created survival random forest prediction model, right, underneath. And then we're looking at all the data, all the information we can gather from the model. By the way, just to make sure, like just in case you're not familiar with the survival model, typically, like if you're working for subscription business or SaaS or software as a service kind of field, you appreciate this a lot because your interest is all about customer retention or customer churn. So you can actually use this to gather information to understand what variables or what columns affects how customer churn or how customer retain. So by easiest way to see is the survival curve. For example, this is like overtime. So the people who overtime is, yes, that means people who work longer hours tend to quit. So for example, in the 10 years period, like only 65% of people who remain, that means 35% of people already left the company. And after 40 years, and then this is about half of the people left, half of the people no. But compared to the overtime is no, that means these people don't work that overtime. So the people don't work overtime tend to stay longer in this company, and the people who overwork tend to leave the company earlier. So it's kind of like totally makes sense. So you're seeing that curve for every single column. But anyway, so let's assume we created this model under the analytics model, and then now like I have the new data that I want to actually predict to see like each based on this information, and then new employee coming, and then like I want to see how this employee is going to be surviving let's say over the next 5 years or next 10 years and so on. Okay, so that's what I like to do. And then when I go here, let me just remove this one. Okay, so this is the data, and then I want to actually predict. And so here, the same thing, add step, right-hand side top, and then under that, you can find predict with model analytics view, select on it. And then you want to select where is that model, like I created under this employee data. And then under that, I should be able to find survival forest. I think this, the last one, I just created it. So I'm going to select on it. And then I want to type which year that I want to see. Like this is 5 years. I mean, as you saw, the survival curve is going down. So it depends which year with survival rate is different. So I want to set like 10 or something. If you don't set this, and it's going to use the kind of median average, I think the median time of the data the model use. But anyway, so I'm going to use 10. So that means 10 years, 10th year, sorry. And then you get the extra columns. This is the predicted values. So the 10th year, the first employee's survival rate is 66%, and the next one is 85%. So like 85% of the chance that this person is going to be still with this company based on all these information. And then based on that, like the default is the 50% cutoff. So like a greater than 50% is true. That means surviving. And less than 50% is actually false. That means probably this person will be leaving. So that's a true and false. You can adjust that in the same dialogue here as well. Okay, so that's the prediction with the survival model. You can use the Cox regression as well. The difference again is the survival random forest machine learning. Cox regression is a statistical model. Okay, so that's pretty much it. One more thing for the analytics is now you can set this under the analytics view. Now it's easier to set the sample size as well. Okay, so now enough for the analytics, and now let's move on to the visualization with charts. So charts, we have, these are 4 things I think it's notable. So number 1, this has been requested a lot by our users. You want to change this like name in the, what do you call it? Legend, sorry. And what happens is when you have multiple y-axis, you assign multiple columns to the y-axis, then the column name will be shown up in that legend. And sometimes column name is not necessarily the kind of name you want to show to other folks, so people want to change it. So you can now change it, rename column name, and then you can change that as well. That will change the y-axis title as well. As a default, you can override it from the property as well. If you assign only one y-axis column and then you actually use color, let's say you assign someone like categorical, let's states or country or something like that, and then you want to then the country name or state's name will be showing up in the legend, and you can also rename as well. That is not a new feature. We introduced that a few releases before, but so now either way, like if it's a categorical from color y or y-axis columns, either way you can change it inside the chart. Okay, and summarize table, you can, the formatting option is, we have added like a header, column header level formatting option for the summarize table. The same thing for the table as well. So like you can, you have more options for formatting. And text wrapping, sometimes you wanna you bring on a tweets data or some like longer sentence data, and then now you can do the text wrap. And so this is the same thing again, more option for table formatting. And the last one for the chart is auto scaling for numeric columns at X axis. So when you assign numeric column to the X axis, and the default is try to categorize, right? So in this case, like I create 5 groups. We call categorize, but some people call it binning or bucketing. So this is convenient when you have something like, so this is like monthly income data. And then if you have like each value of the monthly income to have its own bar, then you don't see anything basically, because nobody has the exact same amount of the salary in a typical company case. So you ended up like not seeing any pattern. So this is where like you want to categorize, and let's say from the $1,000 to $2,000, $2,000 to $3,000 and so on. And that is done automatically when you assign a numerical column to the x-axis in Exploratory. But the problem is sometimes it doing too much. Let's say like you have only 5 unique values in number or 10 unique values in numerical data type column, then you don't really want to create like artificial groups based on the equal width or whatever. So now when you assign only the column with less than 10 values, 10 unique values, and it will keep it as a numeric. And then, but you still like you can change it between numeric and a categorize and either way. But default setting got a little bit smarter. So Okay, so that's the chart, and then now the data source. So data source, we added a Snowflake data source support, and also we improved the ODBC data source support. So ODBC, we improved performance in general. Some of the data source time, you will see some improvements, and then better encoding handling. This is especially useful for multi-byte characters such as Japanese or Chinese and so on. And then the easier setup is before, like you had to basically know exact the location of the drivers and so on. But now, like you can click on this button and it will show you whatever the ODBC data source you set up on your PC, it will shown up here. So all you need to do is just pick whatever the right one. Okay. And then here, the last area, the dashboard. So now you can adjust height and width. So if you happen to be using dashboard, you will love this, because now you can adjust by using the mouse and not just height, but also width as well. And then you can add or delete row easier. Okay. So let me just show you quickly on this one too. So in the dashboard, let's say like I have created this dashboard. Okay. So now let's say like, hey, you know what? I want to actually add more charts between this number area and in this chart area. And then like I can click on this plus button, add above, and then now I have an extra section. So let's include some of the charts. Let's say what I can do. Maybe this chart. Okay, here we go. And then maybe like one more charts, maybe. What charts? Maybe like employee data we are looking at. So how about this chart? Okay. Then, at the top, it's kind of like a super smash. So I want to actually change that, make it bigger. And then here, adjust that a little bit, maybe like this size. And then this one right now is a height is 100% of the screen size. So basically, like when you move, like okay, so what's that? 25%, maybe 25%. I want to do the same amount height, and then like when I click on the run button, and it will respect that setting that I have just adjusted the height and width as well. Here we go. Ooh, there's no data display. I don't know what happened here. I'm gonna just change it. Let's see. Let's say like if I had this one, let's see what happened. Maybe that data frame had some problem, something. Okay, so you get the chart like this. And then one thing though, there's a two options. One is a fit to screen. So based on this, like whatever the available height is 100%. But sometimes you want to have like something like this. There are too many charts, and then it's kind of like clumsy a little bit. So in that case, you can just set the height, and then you know what? Like I want to actually use it, maybe 1720 px, and then what I can do is I can just make it kind of like each section to be kind of bigger, and then so that like, oh, I think this is like 700, it's too big. So I'm gonna just change it to something like this. And then with this, I can still adjust, the size of each section. And then also like I can just change that width as well. So this way, it's not fit, but you can use some sort of like scroll to show all the charts as well. So now like I can see kind of like a scrolling down to see all the charts, and has more sort of like enough size for all the charts to be shown up together. Okay, so that's a dashboard. So like now you can more flexibly design your dashboard than before. Okay, so that's a dashboard. And one more thing, so pretty much that's it for the desktop, 6.4. But there is another enhancement we have made. This is like probably like a few weeks ago, but I just want to use this time to introduce, which is a stats page on the exploratory server. So with the exploratory server, you can share, schedule, and interact with all your insights that you publish, such as data, chart, analytics, dashboard, notes, and slides. So typically way you do is like you create the data. You do all the data wrangling at the right-hand side, or maybe like you create a chart or dashboard, and then now it's time to publish so that you can share or schedule at the server. And so you publish it, and then each insight will have a unique URL. So like you want to open in a web browser, and from web browser you can share with others. And all your insights, sometimes if you publish many and then you kind of go confused which URL. So you go from your account menu, and then you can see like your profile menu, and then you see the my insights. Then it lists all the insights you have published, right? So you don't, by the way, you don't have to publish when you're working on the desktop, and then if that's all you need to do, you can stay there as well. I'm talking about sometimes that you want to publish so that you can share with others at our server or the exported collaboration server that you install on your server, either way. Okay, anyway, so like you can browse your old insights, or you can schedule. So let's say sometimes 6 o'clock in the morning, you want to run it, so like you get the latest data from Google Analytics or from your MySQL server or Redshift database or whatever stuff. So you can schedule that as well. And then you can interact by using parameters. If you use parameters in the exported desktop, then publish it. The parameter also gets published along with your dashboard or charts and so on. Then when you share it, then the person who you share can use this parameter to filter the data, update the calculation, or even update the SQL queries as well. Then you can see the stats for your insight by clicking this 3 dots button. It says show stats, and then it will show you like how many views by the time, like by the week or by the month, by the year, and so on. Also, it gives you the referral information as well. So like you can see like where the people who saw your insights coming from as well. So the problem though is instead of monitoring them one by one, in the previous one, like you have to open each insight, then you get that stats. But can I see all the insights I published together instead of visiting, every single insight? Another thing is you can publish and schedule or use the parameters, but that uses the resources of the quota you are allocated to based on your plan, like a personal, business, or business plus, and so on. But you want to see like how much quota you use. The quota here is like a number of the rows you process every month period. But you want to see like how much remaining, how much you're using, maybe like some of the insights you don't need it, just wasting your resources. So that's where you want to use this stats page, monitor all your insights performance. So this is the same thing. You go to any page of the exploratory.io, and then right hand side top you see your profile icon, and then like underneath you see the stats. When you click on it, and then it will show you that all the views for all your insights you publish, regardless it's note or dashboard or chart and data. And then you see, how many views, how many likes for each, but also how many views on total as well. But here, this is probably more useful when you're doing the scheduling types of things. Then you can see like a total size of the disk. Disk space also has a max is, I think it's like a 1 terabyte, or I forgot, maybe like could be, depends on what plan you are, could be 10 gigabyte to 1 terabyte Z variations. And then the raw process, I think typically start with I think 500,000 or 1 million or something like that. I could be wrong. I have to check out. You can find the more information on the pricing page. But anyway, so whatever the quota you have, then like you can see like how many rows being processed, and then what's the percentage you already use in this monthly period. And then you can see like when's the next when's the day that the number of rows or whatever the quota will be reset. Okay, so this way, like you can be more comfortable using, server for scheduling and interacting and sharing as well. Okay, so that's the stats page, and that's it for today. And then with that, I like to open up for Q&A. A. And also, I'm planning for the next seminar next week, which is I'm going to go back to the explorative data analysis seminar. I have done part one, part two, and then I'm going to finish up with the next one, the part three, which is about correlation and association about the categorical data. Okay, so if you have any question, please let me know if either from chat window or you can unmute yourself and speak up.